I'll start this demonstration by bringing up Dell Cross Savant. Into Savant, I've loaded into the scene tree a platform CAD model for an A380 aircraft. I've also defined an antenna on the top of the fuselage of the A380, and at this location what we'd like to do is simulate the installed performance of an ADS-B mode air traffic control beacon antenna. That will be a blade antenna. We'll synthesize that in Antenna Magus, bring that into Microwave Studio, simulate it in CST Microwave Studio with a near-field source monitor, and turn that into a hybrid stimulation then for an installed antenna model on this A380 in Savant. Let's start the demonstration in Magus. Using Antenna Magus, we've synthesized a design for our ADS-B mode blade antenna. And so once that has been developed, this one's centered at 1.05 gigahertz, we can go to the export mode, of course, and export the model ready for a Microwave Studio project. Here's our imported model in CST Microwave Studio 2014 as synthesized by the Antenna Magus software. You can see here we have the blade antenna. There's a feed point immediately below, and then there's a large metallic ground plane underneath the antenna. That will be set to mimic the ground plane formed by the skin of the aircraft when we incorporate it in Savant. Now, in order to capture the information we need to create the model for the Savant simulation, you can see what we've defined in the field monitor section is something called a field source monitor. The field source monitor is used to capture electric and magnetic fields in a region immediately surrounding the antenna. We recommend setting a field source model for the capture that's about 1/10 of a wavelength larger than the extents of the antenna element itself. If you're simulating an antenna against a ground plane, as we have here, then we recommend that the bottom of the field source monitor be immediately adjacent to that ground plane. Another thing to note in this model is that we've brought absorbing walls right up to the edges of our ground plane. We want to simulate this element under infinite ground plane approximations to capture the currents on the element itself. When we incorporate this in Savant, we won't use the currents on the bottom face actually, because they'll be supplied by the Savant simulation when we run the SBR using the current sources developed off of the electric and magnetic fields on the other 5 walls of the capture volume. When we're ready to export this model for use in Savant, we select a macro that CST has developed under their Results, Import and Export section, and here you can see Export to Savant. This export process will create a result archive in a directory immediately under your CST project results subdirectory. In this case, it will be called Antenna 1, and it will export a 3D model of the antenna so that we can pull that into Savant and at least have it there to show us the orientation of the antenna, and also the near field results, which are going to be converted when we import it into Savant into a series of magnetic and electric current dipole moments. So we export this model, and then we turn to the Savant software. We return now to the Dell Cross Savant simulation environment where we have the A380 aircraft located, and I'm going to place our CST antenna model for the blade antenna just forward of the vertical stabilizer. First, we have to import the CST antenna definition into the scene. So I select the archive that was built by our CST export process that imports the CST model. And now I'll go ahead and place that in an appropriate location about where we would want to locate that antenna on the aircraft. And now let's zoom in the immediate region around the antenna. Now, one of the things that you can see if I turn off the current density box is that the antenna is turned 90 degrees from where we want it to be. So I'm going to adjust the orientation on that just a little bit. I'm going to change that by 90 degrees to turn the element so that it faces in the correct direction. If I turn back on the current density view, you can see our electric currents. I'll turn on the decibel view and change the scale just a bit. You can see the equivalent electric currents and the equivalent magnetic currents. And again, we'll change the view a bit. And there's the magnetic currents. Because we have the ground plane in our original model, we need to define it here to let the software know that that was computed with that ground plane below. And finally, in order to generate the model that will actually be used to source the rays, the small current dipole moments, we generate current sources. And now you can see the current sources. Let me turn off the equivalent current box. And there are the moments. One final interesting feature that you can use when you're putting these models onto bodies with curvature, you can conform or adjust the antenna model to adjust the locations of those moments so that they line up along the normal to the body of the aircraft. And that will adjust this now to fit your antenna model to conform to a non-flat surface in a conformal fashion. This model is ready for simulation. That's all we needed to do, and we're off to simulation now in Savant for the installed antenna performance model. The final step in this process is to show you some results. After computing this on my laptop for about 4.5 minutes or so, I computed about 175,000 angles to show you a complete three-dimensional installed radiation pattern for this blade monopole antenna on the A380 aircraft. Savant also can show you the polar cuts as well. Here's the original pattern for the monopole over an infinite ground plane, but when it's placed on the aircraft, here's the installed pattern in the cross dimension cut. In a cut that aligns with the fuselage, here again you can see the infinite ground plane pattern for the antenna and the installed pattern. This new workflow will make it fast and easy to flow detailed, accurate, full-wave antenna models in CST Microwave Studio to Delcross Savant for installed antenna performance analysis. This integration is fast, easy, and error-free. We look forward to providing this capability to CST and Delcross customers in CST Studio Suites 2014 and Delcross Savant 4.0. Thanks for viewing this presentation.